TDMA, Time Division Multiple Access. Time Division Multiple Access, TDMA, is a digital channel access method that allows multiple users to share the same frequency channel by dividing the signal into different, non-overlapping time slots. If FDMA is like a multi-lane highway where each car stays in its own lane, TDMA is like a single-lane road where cars are released one by one at high speed according to a strict schedule. 21. Where is it used? TDMA was the cornerstone of the 2G, second generation, cellular revolution. While largely evolved in modern 5G networks, its principles remain vital in 2G GSM, global system for mobile. The most famous application: satellite communications, managing data bursts from multiple Earth stations. Digital Enhanced Cordless Telecommunications, DECT, used for cordless home phones. Military communications, Link 16 secure, jam-resistant data links. Fiber optics, PON, upstream traffic in GPON/XGS-PON internet connections. 2. Operation principle: in a TDMA system, the total available time is divided into recurring units called frames. 1. Synchronization: the base station, BS, sends a synchronization signal so all mobile devices agree on exactly what time it is. 2. Buffering: because a user's voice is continuous but the transmission is not, the device buffers, stores, the voice data. 3. Burst transmission: when the user's specific time slot arrives, the device compresses the buffered data and transmits it in a high-speed burst. 4. Reception: the receiver listens only during that specific slot, extracts the data, and stretches it back into a continuous sound for the listener. 3. Mathematical description: the number of channels that a TDMA system can support on a single radio frequency carrier is calculated as where, number of time slots per radio channel. Total available spectrum. Guard bands at the edges of the spectrum. Bandwidth of a single radio channel. Efficiency: TDMA efficiency is the ratio of data bits to the total bits transmitted, including overhead bits, preamble, guard time, synchronization. 4. Frame structure: a typical TDMA frame, like in GSM, consists of 8 time slots. Each time slot contains a burst of data structured as follows: preamble, contains synchronization and address information. Information data, the actual voice or data payload. Guard period, a small buffer of silence at the end of each slot. This prevents bursts from different users from overlapping due to travel time, propagation delay. Trail bits, used to mark the beginning and end of the burst. 5. Advantages and disadvantages. Advantages: power efficiency: the transmitter only turns on during its slot, saving significant battery life. Flexible data rates: a user can be assigned multiple time slots if they need more speed, example for a video call. No duplexer needed: since transmission and reception happen at different times, the device doesn't need expensive filters to separate them. Disadvantages: complex synchronization: if one device's clock is off by even a microsecond, it will crash into another user's slot. Multipath distortion: high-speed bursts are susceptible to echoes, ISI, requiring complex equalizers in the receiver. Strict range limits: if a user is too far away, their signal takes too long to travel and arrives late, overlapping the next slot. 6. Comparison: TDMA versus FDMA versus CDMA. Feature: FDMA, frequency; TDMA, time; CDMA, code. Analogy: different lanes taking turns, different languages, separation by frequency bands, by time slots, by unique code, synchronization, low priority, critical, code/phase, hardware, simple/analog, digital/bursty, highly complex, interference, guard bands, guard time, self-interference, limited. 7. Summary: TDMA is a highly organized way of sharing a radio channel by sequential taking turns. It transformed mobile phones from bulky analog bricks into power-efficient digital devices. While modern 4G and 5G use OFTMA, a hybrid of frequency and time, the fundamental TDMA concept of time slotting remains the backbone of how your internet data moves through fiber optic cables and satellites today. CDMA Code Division Multiple Access, CDMA, is a digital wireless technology that allows multiple users to share the same frequency and time simultaneously. Unlike FDMA, different lanes, or TDMA, different times, CDMA separates users by assigning each a unique mathematical code. The classic analogy for CDMA is a cocktail party. In a room where everyone is talking at once, you can still follow a single conversation if that person is speaking a language, code, that only you understand. To you, everyone else just sounds like background noise. 1. Where is it used? CDMA was the backbone of the 3G, third generation, era and continues to be fundamental in satellite and secure communications, 3G cellular, standards like CDMA1, IS-95, CDMA 2000, and WCDMA, used in UMTS. GPS: every satellite transmits on the same frequency, your receiver identifies them via their unique CDMA codes. Military: used for low probability of intercept signals because the spread signal looks like noise to enemies. 2 Operation Principle, Spread Spectrum CDMA is based on Direct Sequence Spread Spectrum, DSSS. 1 Spreading, each user's low-speed data bit is multiplied by a very high-speed code called a chip code, or spreading code. 2 Transmission, this transforms a narrow signal into a very wide, low-power signal that is spread across the entire bandwidth. 3 Despreading, the receiver multiplies the incoming noise by the exact same code. This collapses the signal back into the original data bit while spreading all other users' signals even further, effectively filtering them out. 3 Mathematical description CDMA relies on the property of orthogonality. If 2 codes and are orthogonal, their inner product is 0. Encoding, if a user wants to send a bit, or, using code, they transmit. Combining, multiple users, transmit at once. The error contains the sum. Decoding, to recover user 1's data, the receiver calculates the dot product of the received signal and user 1's code. Due to orthogonality, all other users disappear, leaving only user 1's data. For frame and code structure, CDMA doesn't have rigid time slots like TDMA, but it does use structures for synchronization, Walsh codes, used in the downlink, tower to phone, to ensure users don't interfere with each other, perfectly orthogonal. PN sequences, pseudo-noise used in the uplink to distinguish different mobile phones. Soft capacity, CDMA has no hard limit on users. As more people join, the noise floor rises, and call quality slowly degrades, graceful degradation, rather than blocking new calls entirely. 5 Comparison, FDMA versus TDMA versus CDMA feature FDMA TDMA CDMA separation frequency time code bandwidth narrow, per user, narrow, shared, wide, shared by all, efficiency low medium high handoff hard, break before make, hard soft, make before break, interference guard bands guard time self-interference, near far, 6. Summary, advantages and disadvantages. Advantages: security, signals are nearly impossible to eavesdrop on without the specific code. Soft handoff, a phone can connect to a new cell tower before disconnecting from the old one, leading to fewer dropped calls. Multipath resilience, CDMA handles signal reflections, echoes, better than TDMA using a rake receiver. Disadvantages: the near-far problem, if a user is very close to the tower, their signal could drown out everyone else. 27 This requires extremely fast and precise power control, adjusting power 800 times per second. Complexity, the receivers require much more processing power to handle the mathematical correlations. 28. Demodulation of CDMA. Demodulating a CDMA signal is essentially an exercise in signal correlation. While the received signal looks like random noise, since it contains multiple users' data all summed together, the receiver uses a mathematical key, the unique spreading code, to extract the specific data it needs. Here is the step-by-step theory and mathematical signal processing behind CDMA demodulation. 1. The received signal model at the receiver antenna. The signal is a summation of all active users in that frequency band, plus channel noise. Mathematically, for $k users, the baseband received signal is amplitude, power, of user. The actual data bits, of user. The unique spreading code, chips, of user. Additive white Gaussian noise, AWGN. 2. Step-by-step demodulation process. Step 1, carrier recovery, down conversion. The high-frequency radio signal is first multiplied by a local oscillator to bring it down to baseband. Step 2, code synchronization, the search. Before any math can happen, the receiver must align its local copy of the code with the incoming signal. This is the most difficult part of CDMA. Acquisition, the receiver slides its local code against the received signal in tiny increments, chips. Tracking, once a match is found, a spike in energy, a delay locked loop, DLL, keeps the codes perfectly aligned even if the user is moving. Step 3, despreading via correlation. This is the heart of CDMA. To recover the data for user 1, the receiver multiplies the entire incoming mess by user 1's specific code. Step 4, integration and dump. The receiver integrates, sums, this product over exactly 1 bit period. The math simplifies beautifully due to the property of orthogonality. 1 desired signal, since is always, 4 chips, this part becomes. The signal collapses back into a narrowband data bit. 2 other users, because codes are orthogonal. The other users remain spread out as low-level noise. 3 noise, random noise multiplied by a code remains random noise. Step 5, the decision phase. The final result is a voltage. A decision circuit, comparator, looks at the sign, if, the bit is decoded as 1. If, the bit is decoded as 0. 3 The rake receiver, handling multipath in the real world, signals bounce off buildings, creating echoes that arrive at different times. A standard receiver would see these as interference. CDMA uses a rake receiver to turn this problem into an advantage. 1 fingers, the receiver has multiple fingers, correlators. Each finger is assigned to a different echo, different time delay. 2. Alignment, each finger displays its specific version of the signal. 3. MRC, maximal ratio, combining the outputs are weighted by their signal strength and summed together. Result, instead of the echoes causing interference, the rake receiver gathers the energy from all reflections to create a stronger, clearer signal. 4. Summary of processing gain. The magic of CDMA is expressed by the processing gain. By spreading the signal, we make it wider but shorter, lower power density. During demodulation, we squeeze the signal back into its narrow shape, which pops the desired data up above the noise floor by a factor of